Let's now apply this notion of a weighted mean, well, that mean for group data, to what we call a weighted mean, which is how most college classes calculate your grade, the final grade you get in the course. In fact, we do this in our course, and maybe I'll do an example problem for the updated syllabus. So essentially what a weighted mean is you apply weights to different categories and then you put scores in there, and then you do this adding and multiplying thing. So here's a sample class where the homework was worth 50 points. That's the weight for the homework. 4 tests are 30 points each, and then the final exam is 50 points, etc., etc. And we've got the student Tong who received these particular values, or these averages in each of these categories, and we want to figure out what is Tong's final grade in the class. Well, I think the easiest way to handle this is to create a table and make sure we line up all of the values. So we have a homework category that's 50%, and Tong's average was 87%, or 50 points. Then we have 4 exams, each worth 30. So we have 30, 30, 30, 30, and he or she, we'll just say Tong, got these scores for each of those 4 exams. Pretty good scores, right? So these are all the tests. Then the final exam is worth a solid 50 points, and Tong got a 92% on that final exam. And then the group project was just 20 points. I wonder if Tong was the one that did the work or if someone else farmed it out. Oh, wait a minute, 92 on the group project. There's a mistake. If we'd all been in class, someone would have shouted that out for me, I would assume. Or, like happens to me sometimes, you wait till I finish the problem and then tell me my mistake. Well, that's totally cool. And then finally, attendance and participation was 10 points. And good for Tong, they showed up for every single class. All right, so this is the data set. And to calculate this weighted mean, we're going to do the same thing that we did with the grouped frequency distribution, where this was like the midpoints and this is the frequency. We could think of it that way. So I'll just put in here midpoint and frequency. No, that's not really appropriate language for what's actually happening here, but in terms of how we're going to calculate it, it's exactly the same way. In other words, we're going to do 50 times. Now here we get a decision. Do we want to put in our numbers as percentages and in the end get a percent, or do we want to put our numbers in as decimals and the end get a decimal? It doesn't matter. I'm just going to put in 87 because then I don't have to type a 0.87, so that's one less thing to type. So it's going to be this times this plus 30 times 91 plus etc., etc., etc. Now, I was wrong. We need to switch these. This we would treat as the frequency. This we would treat as the midpoint. The reason we have to do that is because we're going to add up these values, and that's what we're going to divide by. I believe these add up to 1,000. So I'm going to switch over to Desmos and type this in. So I was totally wrong. The denominator, the sum of all those points for each category was not 1,000. It's some other number that I still don't know because here's how I typed it in. But notice in the top of this, I have the weight of the category times the score Tong got for that category. So here's that 50 times 87%, and the 30 times the 91%, etc., etc., etc. And then in the bottom, there's the sum of all those points. And Tong's grade overall in the class, his or her weighted average is an 88.72%. That's this value right here. So that's the grade. At Jackson College, we also do we convert these percentages into a GPA score. So if this was our class and you got this score, you would end the class with a 3.5 on your transcript.